The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is electromagnetic induction. Students, look at this diagram. Here an ammeter is connected with a coil having no voltage source, having no battery. And when north pole of a bar magnet is moved toward the coil, the ammeter shows deflection. It means that current is produced in the coil when magnet is moved toward the coil. And if we stop moving the magnet, no current is there in the coil. The reading of ammeter becomes 0. Similarly, if the magnet is moved away from the same coil, there produces current that is shown by the deflection of ammeter but in opposite direction. What does all this mean? This shows that whenever there is a change of magnetic field through a coil, there produces current in the coil. This phenomena is called electromagnetic induction. So we can define it: production of current in a coil due to change of magnetic field through it is called electromagnetic induction. Now students, how we can change the field through a coil? There are 3 ways of changing the magnetic field through a coil. Number 1, by moving magnet. Look at this diagram. Here again an ammeter is connected with a coil, and if a bar magnet is moved towards or away from the coil, the magnetic field changes, and changing magnetic field produces current in the coil. The second way by which we can change the magnetic field is by moving the coil, keeping the magnet at rest. Look at this diagram. Here is a magnetic field between these 2 poles of a magnet, and magnet is at rest. And if we rotate a coil in this magnetic field, again magnetic field through the coil changes, producing current in the coil. So second way is keeping the magnet at rest, and by moving the coil we can change the magnetic field. And third way is by changing the current, keeping the magnet and coil at rest. Look at this electric magnet. A coil is placed between 2 poles of the magnet, connected with a galvanometer that shows the presence of current in the coil. If magnet is at rest, coil is at rest, and we change the current in this electric magnet, the magnetic field passing through the coil changes, that produces current in the coil. So these are the 3 ways by which we can change the magnetic field. Number 1, by moving the magnet. Number 2, by moving the coil. And number 3, keeping the magnet and coil at rest just by changing the current. Now students, on what factors does this current produce depends? Number 1, it depends on the rate of change of magnetic field. How quickly the magnetic field is changing in the coil. How quickly the coil is rotated or the magnet is moved towards or away from the coil. This is the one factor on which the current produced due to electromagnetic induction depends. Number 2, strength of the magnetic field. Stronger the magnetic field, more current will produce due to changing magnetic field. And number 3 is the length of the conductor in the magnetic field. More is the area of the coil that is through which the magnetic field is changing, more will be the current produced. Now students, what is the direction of this induced current? Means current produced due to change in magnetic field. The direction of this current will be such that it opposes the cause producing it. Means the direction of this current is such it will oppose the cause producing it. What is cause that is producing this current? Look at this diagram. Here a bar magnet is moved, north pole of a bar magnet is moved towards the coil. When magnet is moved toward the coil, magnetic field passing through the coil increases, and this increase in magnetic field produces current in the coil. The direction of this current will be clockwise because the magnetic field produced by this flow of current will try to oppose this increase in magnetic field, because in this case the cause is increase in magnetic field and the direction of current will be such that it will try to decrease this magnetic field. So current is clockwise. In the second case, when same north pole of a magnet is moved away from the coil, now magnetic flux or magnetic field passing through the coil decreases and direction of current will be such that it will try to increase this magnetic field. So the current is directed anti-clockwise. Similarly, in third case, when south pole is moved toward the coil, the field is increasing, and to decrease the field, current will be directed in anti-clockwise direction. And similarly, in fourth case, the current will be directed clockwise to oppose the change in magnetic field that is producing it. So the direction of induced current will be such that it will always oppose the cause producing it. If cause is the movement of magnet towards the coil, opposition will be a force that will tend to move this magnet away from the coil. So this is how the direction of induced current can be found. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.